This recording is for first hour Algebra 1. It is lesson 9.2, factoring using the distributive property. I'm giving you this video recording because I'm not going to be here on Friday and you need to learn this lesson. What we're doing to begin with is thinking about the distributive property. The example in the red shows you what we used to do with the distributive property. We would first distribute the 2y to the 4y, and also distribute the 2y to the 9. When we did that, we would get 2y times 4y plus 2y times 9. Well, 2y times 4y gives us the 8y squared, and 2y times 9 gives us the 18y. So what's the point of all this? We're going to be taking something that looks like this, 8y squared plus 18y, and getting it back to how it originally began. That's what we're going to be doing today, and that is called factoring. Now the method we're going to use is using the distributive property, or in this case it's really the opposite of the distributive property. So we begin on number 1 by using the factor trees and finding the greatest common factor for 12a squared and 16a. So that's just what we did on a Wednesday. So we break down the 12. We can do 3 times 4 is 12. And now we can break down the 4. That's 2 times 2. So if I'm making my list for 12a squared, I would have 2 times 2 times 3 times a times a. Now do the same thing for the 16a. 4 times 4 is 16, and each 4 can be broken down to 2 times 2. So in my list for 16a, I would have 2 times 2 times 2 times 2 times a. And remember, with greatest common factor, we then look to see what is in both lists. We have a 2 in both lists. We also have another 2 in both lists. And we have a 3 in both lists. So the greatest common factor would be 2 times 2 times a, which is 4a. Now, 4a is not our answer, but we use the 4a. The 4a being the GCF, what we're going to do is factor out a 4a from the original problem. We do this by thinking to ourselves, okay, the first term was 12a squared. So 12 divided by 4 is 3. And so again, we have a squared. What times a, which we already have with the 4, what times a would be a squared? That had to be a. So again, if we wanted to just check this to make sure this first part is right, 4a times 3a is 12a squared. So I'm not done. I have a plus sign. And then we again go through the same process of 4 times what would be 16. That would be 4. And we do not need a variable with that 4 because, again, checking this, 4a times 4 is 16a. So that makes this our final answer, 4a times the quantity 3a plus 4. This is factored completely. Okay, so what's the point of all this? We're going to get to other problems like 2 and 3 and 4 where we don't have to show this much work. We don't have to do a factor tree every time. We don't have to make a list of the common factors every time. So what we can do is we can do that part in our head. With number 2, we've got 3 terms. We see we've got the numbers 12, 24, and negative 30. So what I need to be thinking about is, what can I divide all the 3 numbers by? What can I divide 12 by, 24 by, and 30 by? Well, I can divide them all by 2. I can divide them all by 3. And I can divide them all by 6. So I've got 3 numbers to choose from. But if I look at those 3 numbers, the greatest of those, in other words, the greatest common factor, is going to be the 6. So 6 will be one of the things I need to factor out. Now we see that there are variables in this problem, so it's not just a 6 that I need to factor out. Looking at the variables, every term has an x, so I'm going to factor out an x. Every term also has a y, and I'll factor out a y. Notice that it was not factoring out an x squared or factoring out a y squared, because all three just have one x in common and all three just have one y in common. So go through the same process we did on number 1. 6 times what is 12? Well, 6 times 2 is 12. We do not need any variables with that 2 because 6 times 2 is 12. In other words, 6x times 2 is, 6xy times 2 is 12xy. And then plus 6 times what would be 24, and I just said it. 6 times 4 would be 24. And on the variables there, we want xy squared. We already have xy, so we just need another y to make that true. So check it. 6xy times 4y would be 24xy squared. And then minus 6 times what would be 30? 6 times 5 would be 30. And on the variables there, we need another x. And we need a y, but this y is to the third power. And again, check that to make sure it's right. 6 times negative 5 is negative 30. Xy times xy cubed would be x squared, y to the fourth. And we have factored completely. We basically did that one all in our head without really showing much work. Okay, moving on to number 3 and number 4. So far we've had problem number 1 with 2 terms and problem number 2 with 3 terms. In problems 3 and 4 we have 4 terms now. So in number 3, I need to look at all terms involved. Looking at the numbers 4, 8, 3, and 6, we should ask ourselves, can I divide all of those numbers by the same thing? Can I divide 4, 8, 3, and 6 by the same number? And the answer is no. Really, you can only divide them by 1, but that's not going to change anything. So, rethink this. Can we group 2 things together that can be divided by the same number? Well, yeah. We can group the 4AB and the 8B together, and we can group the 3A and the 6 together. The 4AB and the 8B can both be divided by 4 and also a variable, b. So we can factor out a 4b just from the first 2. If I factor out a 4b just from the first 2 terms, inside my parentheses I would have a plus 2. And again, I can double check that to make sure I'm right. 4b times a is 4ab plus 4b times 2 is 8b. So I factored completely on that first part. Finish it up, I've got to copy down the addition sign. It comes straight down. And out of the last group, I can factor out a 3. 3 is the only thing we can factor out of the last group. Both terms do not have the variable a. So what's left over? A plus 2. So I need to take a step back and look at my answer and see if anything stands out to me. So in looking at our answer here, I see that we have a plus 2 in parentheses here, and also a plus 2 in parentheses here. That's not a coincidence. We should have that happen every time we factor by grouping. So this isn't my final answer. Since both of these have the a plus 2 in common, I can factor out the a plus 2. Essentially, that means the things that are highlighted, pull it out, and what's left over would be a 4b and a plus 3. Notice in the final answer that there is not an addition sign between the two parentheses. This is multiplication. So if we wanted to check this, we could check it by foiling. And if we FOILed all of this out, in the end, if our answer is correct, we should get 4ab plus 8b plus 3a plus 6. How the problem began in the first place. Okay. Now, on number 4, again, we see we have 4 terms. So we want to factor by grouping there as well. And if I look at the terms, I may not want to group in the order that it is written. I can always rearrange things. So I think I'm going to rearrange it and so that my 2's are together. So 2xy minus 2y. And my 7's are together. Plus 7x minus 7. Remember that the sign in front of that term goes with it, even if you move it. So now let's factor by grouping. We can group the first 2 and the second 2. Out of the first 2, we can factor out a 2y. And if we factor out a 2y, what's left is x minus, now this is what confuses some people. I can't say x minus 2 because 2 times 2 would not be 2y. It would have to be x minus 1 because 2y times 1 is 2y. Okay, just like on the previous problem, we recopied the addition. And out of the last group, we can factor out a 7. So that leaves us with x minus 1. And here again, no mistake, we have the same thing in both parentheses. So we're ready to write our final answer. X minus 1 times what's left over? 2y plus 7. If you're struggling seeing where that extra or that last part came from, there's the 2y, there's the plus 7. Final answer, x minus 1 times 2y plus 7. Alright, now that we've had a good taste of factoring, the next thing we're going to look at on the back side is dealing with solving. So our rule for solving here is called the zero product property. And it states that if you have two numbers, a times b, and it's equal to 0, then either a must be equal to 0 or b must be equal to 0. Or even both a and b are equal to 0. And it's the last case that we must consider. Both a and b are equal to 0. So how do we use that? Well, we use that in a problem like number 7 where it says solve. So we know in the end we're going to have d equals some number. So we've got d minus 5 times 3d plus 4 equals 0. Notice that two things are being multiplied together. And in the end, the things multiplied are equal to 0. So since that's the case, I can take each of those things being multiplied together and set each equal to 0. D minus 5 equals 0. And the other would be 3D plus 4 equals 0. And we use our basic algebra skills. D minus 5 equals 0. We should add 5 to both sides. So D is equal to 5. And for 3D plus 4 equals 0, again using basic algebra, subtract 4 from both sides. 3D equals negative 4. And divide both sides by 3. D is equal to negative 4/3. Negative 4 over 3 does not divide to give me a whole number, so I'm keeping it as a fraction, negative 4/3. My final answer is 5 and negative 4/3. I don't have to have those numbers in any certain order, but there are just two answers, 5 and negative 4/3. Okay, so number 8. Number 8, same idea. We've got two things being multiplied together and it's set equal to 0. So write it out. X minus 2 equals 0 and 4x minus 1 equals 0. For x minus 2 equals 0, we're going to add 2 to both sides. That gives us x equals 2. And for the other, first add 1 and then divide by 4. X is equal to 1/4. So our answer would be 2 and 1/4. Our last two problems are a little different. We're going to be using the same idea of setting something equal to 0, but if we look at 9 and 10, there is not a 0 in the problem. There's nothing written something equals 0. So in order to use the property, the zero product property that we just talked about, we had to have equals 0 written in the problem. So we can manipulate this. We can make our problem look like that so that we have the equal 0. And if we do that, that means we've got to move something. We can move the x squared to the other side, or we can move the 7x to the other side. Doesn't matter. Let's move the 7x. If I move the 7x, I have to subtract 7x from both sides. That gives me x squared minus 7x equals 7x minus 7x is 0. So equals 0. Now we have the equal 0 in our problem. But we're not quite ready to set things equal to 0 and solve yet. Because in order for that to work, two things have to be multiplied together. This is not multiplied together. This is subtracted. So we need to factor. By factoring, again, this is what we did on the front side. What can we pull out of x squared and negative 7x? Well, we can pull out just an x. So what would be left over is x minus 7. Now that we have factored, we have two things multiplied together. We have x times x minus 7. So that would be saying that x equals 0 and that x minus 7 equals 0. This one, x equals 0, is already solved. There's nothing else I need to do. The other one, x minus 7 equals 0, add 7 to both sides, and we get x equals 7. So our solutions are 0 and 7. Okay, last problem, problem number 10. Same idea, we don't have equals 0 in the problem, but we want it there. So we need to move one thing. We can move the 4y or we can move the 12y squared. Just for the sake of being different, let's move the 12y squared this time. That'll give us 4y minus 12y squared equals 0. 12y squared minus 12y squared is 0. Now again, remember, factor. So we can factor out a 4y. If we factor out a 4y, what's left is 1 minus 3y. So now we're ready to set things equal to 0. 4y equals 0, or 1 minus 3y equals 0. On 4y equals 0, divide both sides by 4. 0 divided by 4 is 0. On 1 minus 3y equals 0, we need to first subtract 1 from both sides. That will give me negative 3y equals negative 1. And divide both sides by negative 3. Y is equal to positive 1/3. So that solution is 0 and 1/3. Okay, we have reached the end of our notes for lesson 9-2. First hour, you need to do the Your Turn assignment, which is printed on your notes on page 484. That's numbers 1, 4 through 8 even, and 10 through 15 all. You should take about 5 to 10 minutes to do these problems and review your answers out loud before starting on the homework assignment. The homework assignment is also printed in your notes, and this homework assignment from the book is due for you on Monday. We will be taking a quiz on Monday as well. If you need any extra help, you're more than welcome to rewind the video and watch it again, or pause through the video to make sure you have everything copied down. Again, remember, do the Your Turn first, review your answers, and then start on the homework. Have a nice weekend.